Okay, folks, we're going to go ahead and kick off the panel here. I think since it's just myself and David, we're just going to make it a conversation, and hopefully you all are engaged in it too. The first thing I'd like to do is kind of take care of some administrative things that I think all of us moderators are supposed to do. So the first thing is you make sure that you're in the right seminar. So this panel is a discussion of the intersection of energy, research and development, focusing on the impact of AI, data centers, and the technological advances in the energy sector. Some of you may have heard David on some of the panels earlier, quite an extensive background in AI and energy. I've got somewhat of a varied background in energy. And if General Boy shows up, I think he'll give you more of a policy and larger overview of what's happening on the global stage as far as AI, data centers, and energy, that close relationship there. Another couple of administrative announcements. Let me get through these, and then we'll kick it off. Collins AI, keep your new BEYA friend and connections close. Sign up now for the Collins AI chat and keep the conversations going long after BEYA 39 fades. Make sure you have your badges scanned as you come in or depart. And if you're here for CEU or PDH credits, make sure you register online at Morgan State University table and scan your QR code and follow the directions of the room monitor just outside the door. At the end of the panel, at the end of the event, there will be surveys. Please participate in the feedbacks. Your feedbacks help us, make these events better and better. So that would be most appreciated. Presentations, we don't have any presentations unless General Boyd comes with some presentations. If we do have those presentations, they will be available on the slideshare.net/ccmag site. And a reminder, when you have questions, could I ask, this is being recorded, so when you have questions, could I ask you to stand up to the mic so that your questions can be heard, not only by the participants in the room, but the participants who will be either listening to the recording later on. The STEM City chat, continue the conversation. We invite you to continue this dialogue via the STEM City chat and any other social media type apps that you have out there. We'll start the conversation off. I'll let David introduce himself a little bit, and we'll kick it from there. David?
Well, thank you very much, Colonel Trimble. My name is David Jones, and I'm the CEO and founder of Lumina Energy. My background is in software engineering. I'm also a technologist. I'm based in Chicago, and what we do at Lumina Energy is create a virtual power plant manufacturing system that integrates into municipalities and global governments. Basically, what a virtual power plant is the opposite of whatever your energy provider is for the city that you live in, meaning they create the energy, they share the energy through power lines, and then you're able to charge your phone or cook or what have you. A virtual power plant works effectively like creating basically two systems. So you have battery storage, and then you have energy generation. So on the energy generation side, we're able to leverage anything that produces electricity. So that could be hydro, geothermal, solar, wind, you name it. And then we integrate that into our system. Then we also integrate battery backup, because once energy is generated, if you don't use it and don't store it, it's going to dissipate. So all of that is connected together with a piece of software called an energy management system, which leverages artificial intelligence to be able to monitor what those resources are doing, like the overall health. We are also able to forecast the needs of our partners, and then we're able to disseminate that energy back into the grid. So that's the long and short story of me.
Fascinating. I'll dig into that a little bit. I'll give you a quick introduction of myself. Al Trimble, retired Marine Colonel. My last command, I was the commanding officer of Marine Corps Logistics Base in Albany, Georgia, where we experimented with several types of different energy platforms so that we could design a self-sustaining base. So In the event that there was some type of natural or man-made disaster, you would have a base of operation that could sustain warfighting readiness all on its own, without the use of the local grid. And we did that through several partnerships with the local community and local industry. We've had biomass steam electric generation that we use with Procter & Gamble. That was about an 8 megawatt opportunity that we had with them. We also had a landfill gas generators that very common these days that we have with the local community. It was kind of a win-win. It provided electricity for us. It helped the local community dispose of trash, and it also helped them generate income to do that. We also had some experimental technology called a BEYA, or it was a bio. A two-way heat transfer system called BEYA, and I forget the acronym now. But what it did was it stored energy in the world. It stored the heat from the summer into the ground and retrieved it during the winter, and did that vice versa. And so a system that probably one of its kind in the Netherlands, but you actually have one in the Marine Corps base in Georgia. And so with all of those energy-saving initiatives, we were able to sustain a war reserve base that pumped out, that made sure that anytime the Marines had to go any place, any climb, any place, anywhere in the world, their warfighting equipment was always ready. And so you can't ask for a better system than that. And then one little caveat, during the tornadoes that hit southwest Georgia, that base was the only entity that had power for a couple of days and became a stationary platform for FEMA to do recovery operations in southwest Georgia. So real life scenario, real life things that happen as well. There was some other initiatives that we did. We worked a lot with IBM early on when they had the early advances with IBM Watson program to design AI models to take to gather all of the data that was generated from all the PLCs and other sensors across, energy sensors across the base to maximize the efficiency of those resources. So lots of things going there. But before I go too far off course, I want to make sure that we hit on what you're here for. And I know many of you are here for AI, data centers, and energy. I recently attended a meeting with NVIDIA. And NVIDIA has this new tech stack. Typically you'll see like a transport layer, operating system layer, compute layer, data layer, and so on and so on. But now people are starting to realize the importance of energy and the need for energy and the thirst for energy that the demand for AI is creating. And so I'd like to dig a little bit about that into. I'd like to dig a little bit more into that. But I want to take a question or two from the audience to make sure that we're hitting on some of the things that you guys are interested in. Questions? Yes, sir.
Okay, my name is George. Okay, can you hear me?
Yes, we can.
My name is George Redmond. I'm a CEO of a company in Maryland. The company's name is RadBioQ, and we specialize in developing artificial intelligence for AI-powered biotechnology for precision medicine and healthcare. That's what we do. And by training, I'm a radiation physicist, and I also did work in artificial intelligence for a long time in that field, in medicine. So my question is about these new nuclear reactors, these modular small reactors. France has been using small nuclear reactors for a long time. Matter of fact, a great deal of their energy is nuclear power. Okay, so over the years, nuclear power has become very efficient and safe. Actually, they've done really good things with how to manage the waste. So my question is, there was a recent announcement that there was going to be experimentation with Amazon with a modular small nuclear reactor in Virginia. Do you feel that that kind of technology has a role to play for supplying power to data centers, which are energy hungry right now and soaking up all the energy around the country?
David, you take that?
Yeah, so I mean, that's a fantastic question, as a matter of fact, and it's very much within my wheelhouse. So part of what a virtual power plant is and what I was explaining is the fact that we're able to leverage all forms of energy generation and energy storage. Now, there's been a huge amount of stigma based on a few isolated incidents within kind of nuclear fallout, such as Fukushima, 3 Mile Island, and so forth. But in the larger, I guess, frame of mind of on a global scale, there are a number of nuclear facilities that are online, and based upon the amount of I guess, load that is required for artificial intelligence to run and to have a high bandwidth for computational power, it's important to be able to pull all of that together. So I'm sure you probably heard about what's happening with Meta and how they're buying their own modular nuclear facility to do exactly that same thing. So in order for us to keep up, because right now the global scale is still at gigawatt level, and I think that that's a relic of the past. Until we move to terawatt level and are able to have what's called distributed energy resources located all over the world in strategic positions, it's going to be very difficult to keep up with the global demand for like large language models like a ChatGPT or DeepSeek and things of that nature. So I think in the near future, it's very important that we begin to leverage more nuclear, more things that can easily be placed online and have minimal to low upkeep. Hopefully that answers your question. Can you go to the mic?
To the mic, please. Thank you.
So, in regards to that, so I was a nuclear engineer for about 13 years. I've supported over 10 nuclear plants within the states. There is a substantial licensing process that goes for firm nuclear generation. I was an engineer who oversaw the executive orders that came out, and I basically was the benchmark, I ran the benchmark plant and executive order responses for when Fukushima happened to respond to that and address that. And I was also overseeing a couple of new plants that were happening, which was South Texas projects, units 3 and 4, which was by Toshiba, I believe, whose plant, Fukushima, they were also owners of that as well, too. So we do have new plants that just came online, Voto, which is using the AP 1000 units. So that's a big accomplishment, but the time it takes to get licensing is substantial. For the existing nuclear plants that are online right now, it could take 5 to 10 years just to get a license renewal for a plant that's already generating power. And if you're talking about firm power and you're talking about anything over a few 100 megawatts, it could be substantial in a very long time. And just to do like maybe one unit, it's $1 billion investment in itself. So the AP WRs are great considerations, but there's different regulatory requirements across seas compared to what it is in the States, and it's a lot more difficult to come online. From a research and development standpoint, you may be able to get a nuclear facility online a lot quicker, but for it to be firm, a generating source that can tie to the grid is a very long, extensive, costly process and has to be approved through licensing. I hope that helps.
No, that did. That, very good. Thank you. Any more comments in regards to that?
I actually loved that comment, and thank you very much for that. So fortunately in the United States, because we've begun to move toward more free access and implementation of small-scale energy generation, you have small, for instance, solar farms that have a capacity of less than a megawatt that you can place in strategic locations, and you can do this at volume and at scale, so you can have more or less the same amount of energy output as a nuclear facility, and it would take a fraction of the time and a fraction of the cost to get that up and going.
Very good question. From a few years back when I sat on some of the Atlantic Council's energy forums, that was an up-and-coming thing. Now it seems to be more prevalent. We see legislators moving to speed up some of the policy implementations of it. I do, in my circles, I see less of a barrier, or I see people starting to understand that the need for nuclear power or even modular nuclear power plants is starting to become a more mainstay. I would suspect that we would see it sooner than later. If you look at all of the data centers that are going up, one, in the local communities here, and the local community having some of the issues with some of the power draw of it. I mean, some of these hyperscalers can take up to 100 megawatts of energy or more, right? While the average data center is probably in the neighborhood of 5 to 10 megawatts. Mm-hmm. And so when you're consuming that much power, and to put that in perspective, you're talking about charging maybe 400,000 electric cars. I mean, that's what you're talking about charging when you talk about a hyperscaler or something like that of about 100 megawatts. So yeah, I certainly hope to see some progress in that area.
Yeah, and I mean, and just to piggyback off of that topic, there's also the matter not just of regulatory issues, but of public discourse. So being able to convince the general public that nuclear is good and it's not bad is a very hard lift, considering you look overseas and I mean, obviously there's a war going on in Ukraine, but the nuclear fallout from Chernobyl still exists to a modest scale. Like, I actually had a chance to visit Chernobyl a few years back, and I'm okay. But to convince the general public that this is okay for their city and that it's not going to turn everyone into hulks or something is a completely different story. And yeah, that's also another facet that really needs to be covered. And I think the only way to really do that is to set up a program with people that look like us to have those conversations.
Yes, ma'am. Yes. Come on up. This is a conversation. This is what
Adding
we do.
to that, because
Yes.
I've been in the energy industry for my 20-year career. You have the commissions in each state, and then you have the energy groups, advocate groups. Constantly, the utilities have to talk to the public about their opinions and their perspectives on it, right? So this is an ongoing thing. This is for existing generating facilities having to have a response constantly, not just for the commission, but all the advocacy groups that may be for or against nuclear or any other type of other forms of generation too that they have to deal with. So even if somebody has the proper funding, even if they can get licensing, even if the commission approves it, if there's an advocacy group that challenges it enough, that could stop a project from proceeding. There's a lot of projects that are on the table right now. They have not been able to move forward because these advocacy groups are really putting pressure on them and preventing them from moving forward, either with building, acquiring the land, bringing up concerns with the EPA. There's just a lot of factors that go behind being able to create new generation. So just keep that in mind, because I mean, there's so many different sources or technologies we can implement, but there's always a group that's challenging it. And this is a constant, whether it's new generation or existing generation. Okay.
Thank you. So let's peel that back just a little bit more, because a lot of the students are here to look for opportunities and see what those opportunities are in that space. So as we talk about the need for STEM talent that support these career fields, and the drivers of AI, and the drivers of data, and the drivers of these energy needs, I'd like to look over to David a second and talk about what are some of those in the next 5 to 10 years, what are some of those career paths that you think will open up or are open or would provide an opportunity for a lot of talent, a lot of STEM talent that we have here?
You know, and it's a fantastic question, by the way. So alongside of owning Lumina Energy, we also own Lumina Energy Academy, which is a workforce development program, and we have successfully trained and or hired hundreds of people in the last, I guess, 4 years or so. And one of the burgeoning new fields that we've put on the market is called a virtual power plant technicians. So we needed this to be filled. There were no people that were offering this program locally, regionally, nationally, or even internationally. So we worked with a number of advocacy groups as well as community-based organizations to get a fund together and provide that opportunity. So as we move further and further into distributed energy resources and hopefully lobbyists in the oil and gas industry don't have too much to say, the propagation of a sustainable energy economy will become more and more prevalent. So looking at the available career paths that one might take, you also have, like even from an entry standpoint, most people don't even realize that there's something called the solar triangle. So you have the actual creation of and I'm just specifically talking about PV, photovoltaic space. You have the creation of the solar panel, which is obviously the origin point. Then you have the implementation of it, and then eventually you have the decommissioning of that. And everything in between requires so many jobs, so many different skill sets to really take place and manifest. So one thing that comes to mind that people really are not focusing on is solar site surveying. And now that drone technology has become more widespread, you have the use of something called LiDAR. Now, hopefully everyone knows what LiDAR technology is, which allows us to, for instance, go on a barren property and understand what the topographical constraints are, or just the land overall, to provide a more complex land and comprehensive land survey. So I mean, even if you've never had any interest or any background in the renewable energy space, like that's a great jumping off point. But for something that's more complex, that deals with artificial intelligence and machine learning and things like that, being able to create a hybrid program around virtual power plant techs, I think, is going to become the future. Not to mention getting into the new technological space around technologies that haven't even begun to kind of manifest. Like one thing that I was talking about with my team is beginning to break into the tidal industry. Tidal energy has not really manifested the way we want to, but seeing as how day or night this is going to work based upon the lunar cycle, it's something that really needs to be harnessed, but you only have a handful of companies doing that. So one thought that came to mind in the near future is that we would work with the United States government, the Department of Energy specifically, to create an entire grid of tidal turbine systems just offshore that would work 24 hours a day. So naturally with that, you need tidal engineers, you need mechanical engineers, you need people also to work on turbines and things of that nature. So I guess, I mean, I'm just spitballing ideas right now because this is a conversation, but these are some things that come to mind that we can begin to act on immediately.
No, that's fantastic. And I think, you talk about distributed energy resources. Within that, for the entrepreneurs out here, there are huge opportunities there. You want to expound on that a little bit? Talk about the ability to make money from other people generating electricity and you distributing it.
Absolutely. And by the way, this is a shameless plug, but we actually do have a vendor's booth downstairs. So if you want to learn more about some of the entry points to becoming an entrepreneur within the space, you can check out some of the things that I've invented and manufactured, and now we're are helping to build out our facility. But I mean, what comes to mind now, solar has become really the poster child for renewable energy. So there's like everything is, what, it's really funny. This is something, I just had a conversation with my engineer about. And do you remember, most of you all are old enough to remember back in the 80s and early 90s when if you slap a clock on something, that it becomes basically a new product. Well, now that thing has become, if you slap a solar panel on it, now it's a new product. So you have like solar-powered backpacks and solar-powered coffee mugs and things of that nature. These things are easy to come by, they're easy to manufacture, and you can easily get out into the market and have little to no competition. But then there's also like wind technology. So being able to create a new, and this is a pun intended, I guess, put a new spin on that. Being able to set up like a small scale wind turbine that can fit in someone's backyard or on their roof or what have you. That's also really, really compelling things to get into that are low lift. Not a whole lot of upfront capital has to go into it. What about you? What are your thoughts?
Yeah, no, I do hear that. What, you know, as we were talking earlier, you know, some of the panels that I have said on earlier, we've had folks who primarily focused on ensuring that those who are left out are included in some of the energy development or some of the new developments in energy that are that's creating wealth, right? And you talk about distributive energy resources.
Yep.
So, as an example, if you had a solar power roof on your house, right, and you generated more solar than you actually could use, then you would use his distribution system, but you would get funding from it, right? And then most people see this today or have seen it in the past where it's minimal. But with the advances in wind technology, solar technology, it is becoming more and more profitable. And what it allows us to do, and so if you have, let's just say you have communities that need to generate income to provide, you know, resources or provide activities in their neighborhoods. And so what we start to see are whole communities utilizing this method to share excess energy or sell excess energy to provide for the resources within their community. And so that is another opportunity for you out there as well. So it's just something to think about as you go through your day, or as you notice some of these neighborhoods that are in these cooperatives. But it's a fast-moving idea, and for the right entrepreneur who knows exactly what they're doing or have a vision of what they want to do, this could be a possibility for you. So.
If I can piggyback off that, by the way, you brought up a really good point. As I mentioned earlier, with the solar triangle, there's all of these jobs that need to happen in order for solar panels to work efficiently, to be created, and ultimately to be decommissioned. One thing we haven't talked about is maintenance. These things need to be maintained. Anything that's man-made, you gotta fix it. It's going to eventually break, or something's going to happen with it. So the way solar panels work is based off of surface area. The amount of photons and electrons that those panels are able to gather will ultimately decide how much, what the efficiency level is for those panels. Now, one thing that I would recommend to those who are interested in starting a small business in the maintenance of that is to create a solar panel power washing business. It's very simple. You only need a power washer, and you just need to not be afraid to fall off a roof. Also, subsequently, what I've come to realize, because I am in the manufacturing space, there's a ton of programming out there for workforce development to get people to become solar panel installers. But one thing that's really, really lacking is there's no one out there who can repair the systems once they do break. So it's like, fine, okay, so you can install the panels, they work, but eventually those systems will break down, or they will need the parts will need to be replaced. So what I would recommend is to become a contractor with your local solar panel manufacturer or installer or what have you, and then just credit yourself, get all of the necessary certifications for your area, and go out to fix inverters or conduit or do pipe bending, things like that. Those are really, really useful things that are extremely underutilized.
No, thank you, David.
Hi, Rafiq Thar. I have a question on your product for virtual power plants.
Sure.
On what scale do you work at? Is it at the home scale or grid scale, or can it do both?
Yeah, so we actually work all the way up to the governmental level, and we're implementing an entire program with the Colombian government as we speak. But we mostly work with small-scale utility of devices, so that could be residential solar, which means it is relegated to a house, but we've expanded up so just for clarification, we have an asset portfolio that's worth about 2 gigawatts right now. So we're capable of servicing a house, and once again, another shameless plug, we do have a type of portable power station that I would love to demonstrate for you downstairs at the vendor section that enables homeowners to basically share back that energy, what Colonel Trimble was talking about. So that effectively creates what's called a sustainable energy economy, where you can enable peer-to-peer energy sharing. So micro scale, we can work with a household. We can even work with vehicles, by the way. We've implemented a type of system now that enables us to retrofit large vehicles like trucks, for instance, and turn them into assets for us. So we can work with houses or small scale stuff all the way up to governmental level.
Thank you. Yeah.
Go ahead, sir.
Hello. My name is Bakari. I'm a graduate student at the George Washington University.
Can you speak up a little bit?
Okay. I'm a graduate student at the George Washington University doing research on finding defects on solar panel using convolutional neural networks. So I have two types of questions. The first one is for research and development, and the second one, as most of the students here, is for like what businesses are looking into students. So the first question is, now we're seeing AI being integrated into a lot of products currently. We've done some classes in sustainability where they talk about enhancing the grid reliability or microgrids using some AI tools, some model tools of AI. I wanted to ask from a research standpoint, what are some of those tools you guys are leveraging or integrating into the business, like monitoring or detecting defect on solar plants or any type of microgrid, to be honest? You mentioned drones, LiDAR, or any other type of monitoring. And once the microgrid comes down or just a residential system comes down, what are some of the tools you use, especially from an engineering standpoint, to restore the system? Now, from the second perspective, the student looking for a job, what are some of the skills you look into a student, especially in the machine learning field or from an engineering field? Is it like whether it's computer vision, LLMs, integration into the solar world, the energy world? Because I'm seeing AI integration in a lot of tools right now, in software development, in data science, but what are some of the tools you guys are researching in the energy industry?
That was a lot. Okay, so let's unpack that first part. Can you run me through exactly what you want to ask?
Oh, so for some of the microgrids,
Yes.
so, to enhance the system, they're using some type of sensors, for example.
Right.
Or there would be sometime a drone monitoring the area of a small power plant, solar plant, for example.
Sure.
Taking pictures or feeding through them a computer vision model and see what are some defects on solar panel or if some arrays of PV modules are down. I'm asking from a research standpoint because that's really academia right now. I've seen only in classes. I haven't seen business example of doing it. So I'm asking if there are businesses that are integrating into that or if you are thinking into integrate that for some of the power
Gotcha.
plant,
Okay.
for example.
All right. So fortunately, because we are a small business, we're a privately owned company. We don't necessarily work with industry standards for technology. Because we do manufacture our own, we've realized that that's become way more cost effective and way more useful down the road because we understand how the systems work and we can kind of shift if things need to be modified. So in terms of kind of sensor tech, we use artificial intelligence. We use something called an AIoT sensor. And so AIoT sensors are placed in each of our assets. That could be either energy generation or storage. And that from itself allows us to get a bigger picture of all of the assets within our 2 gigawatt portfolio, what I mentioned earlier. And then from there, we can actually see if there's any sort of hiccups in the system by using our energy management system, what we call Parsec. But I guess, are you talking about from like a environmental perspective, or
I'm talking about the monitoring perspective.
from
like-
the monitoring? Well, there's basically two levels of monitoring. Monitoring comes from the hardware perspective as well as environmental. So from an environmental perspective, we don't necessarily use any tech for that. We have our technicians to go out and they'll just kind of take a lay of the land to understand what's going on. And if they see any defects, then our technology will first, our AIoT tech will be the first to kind of red flag that, if you will. And then they'll go and check out whatever area that needs to be improved or to replace parts or what have you. I hope that answers your question.
That does.
Okay, now what's the second part?
Now, the second part is for being a kind of spokesperson for my fellow students here, what are some of the tools, especially from an engineer's background, to technology that you're looking into a student specifically? I've just had a very long talk with Mr. Jeffries at your company's booth, and I wanted to build up more onto that.
Okay, so this is such a loaded question. I want to find the best way to answer it and, of course, be respectful of time. So think about it this way, right? We have to first design those systems.
Yeah.
The first part of that is we use a piece of technology, and it's one of the very few that we use called Aurora. Aurora is used specifically for PV design. So we're able to understand whatever the requirements are for either ground-mounted or roof-mounted or what have you. And then our electrical engineers, like Jeff, who you met down there, are the ones that help to implement that. Once the system is online, then we'll usually have a virtual power plant technician that comes in, and he uses our hardware, which I'm guessing that you got a chance to see. And fortunately, because it's chock full of all kinds of things, and I'm sure we'll talk about blockchain in a little bit, but we provide audited transactions for each of the energy trades that occur, as well as all of the things that happen in between. So we use what's called a GPU, if you're familiar.
Yeah.
Yeah, so the GPU enables us to create these computational movements. We use an RTX, by the way. So that RTX is basically the hardware behind that. We have sensors that are built into our inverter, we have our own proprietary inverter called it's called an Empower virtual power plant inverter, specific to our industry and our niche. So that's what we would do from kind of day-to-day operation. And then beyond that, it's really just kind of eyeballing to make sure things work.
Thank you.
And by the way, this is just one small tidbit. So around the United States, you're going to find other virtual power plant companies, but to be honest, and this is no slight to them, but they're really just, they're software companies that are moonlighting as a virtual power plant company. Because what they'll do is they'll go door to door and sign up people to kind of be part of their subscribership program to quote unquote share their excess energy, but their technology is not doing it. Yeah. It's anything that's, as Colonel Trimble mentioned, anything that's left over is just arbitrarily being shared back into the grid. So that's what's called a static environment. We have a dynamic environment, which means that we can actually remotely control when and where those transactions take place.
Okay.
So hopefully that makes sense.
That makes sense. Thank you very much.
Hello, my name is Allison Jones. I'm actually a mechatronics student at Morgan State University. I wanted to ask, do you guys have any insight on some of the trends that are happening in nuclear power plants in terms of like their research and development?
I think the woman in the back might be a better.
I think she'd be a better resource for you.
So I guess I have a particular interest in thorium reactors. I think they're typically molten salt reactors, but I'm not too sure, and I wanted to try to get more insight on that.
Yes, please.
Yes, please.
It's a conversation.
I mean, you could probably just go up there at this point.
Primary sources.
Hey, ma'am?
Primary sources
Ma'am.
for, yes.
No, this is great. If I can spell your name right, I can put it up there.
I can only speak to nuclear,
All right, nuclear.
battery energy storage systems.
I'm also interested in that.
Okay, I can talk to that, okay, too, but there's a lot of technology related to that. I'm putting a plug out for that for everyone. Okay, in the States, there's a lot of research and development, such as what you're talking about. There's so many different technologies, and I mean, these different type of technologies have been studied for over 50, 60 years. Some of it is not new. It's just that there has not been enough research into it where it can be approved to be utilized in commercial uses. Right now you have plutonium and uranium. Those are the primary two sources that you'll find across the states for sources of fuel, okay? That is a possibility, but it's not likely to be approved for commercial licensing. But more research and development, there's opportunities for funding. Actually, I don't know what I should say, I can't say. There's a lot of opportunities for funding. If you do more research into it, and definitely look with the Department of Energy in that regards, they are always looking for chances to see what's out there. I know the other gentleman talked about the advanced power water reactors, the APWRs, okay, because that's kind of like where we're going, because they're smaller reactors, and those technologies are being used in different countries. And there's different type of fuel sources that are being used elsewhere too. They're already approved for commercial generation in different countries, but in the States, we're not there yet. It's a very long, slow process to get to where you could do some of these things that are being done in research and development, but nevertheless, they should be pursued, you know what I mean? And they definitely should be something that should be kept in the forefront, because you never know, especially with a lot of, you heard what happened with 3 Mile Island. You never know, and that was a decommissioned plant. You never know what could happen. There's a lot of other plants that were considered for being decommissioned and being taken offline, and now they're not. Now they're going for license renewal, or they've been just completed, the ideal has been squashed, and there's other plants within the states that have been decommissioned that we could potentially bring back online. So there are opportunities there. We may not necessarily use the new technology that you're talking about, but it's possible. We need it. We need the generation. And now we're going from, I'm sorry, I'm trying not to make this long-winded. Now we're going from talking about megawatts, which most units are based off of, and now we're talking about gigawatts. Like, we need units that can produce gigawatts. And it's not that much technology that can generate that, you know what I mean, in a small footprint, because we're running out of space, and a lot of type of generating sources like that need water to be able to produce. And how many sources do you have of that across the country? So, right, sorry.
Nope, stay there.
Stay here. Oh.
I was gonna say,
We got a new panel member here. Absolutely.
I did also want to ask, in terms of the practicality of actually reaching that gigawatt hour, what are some of the technologies that are getting popularized that can actually produce that? Does that make sense?
Battery energy storage.
What?
Oh, did I say that?
Yes.
Battery energy storage.
BESS.
For sure, BESS, yes. And this I love, because the panel is talking about DER, which is a really big thing that's growing. We always have the need to diversify the distribution side of things, and that's kind of like where the focus is, and having the combination of PV, which is solar, mixed with battery, to be able to combine that, because BESS a lot of times is the batteries discharge, you know what I mean? They can't, you just like think about a battery in your phone or any other device. Over time, it's going to degrade, and it has a useful life, right? So you may be able to depend on solar during some prime time of day, like the hours between 3 and 5, and you get a lot of solar, and then now you don't have to depend on solar. Now you can switch over to the batteries that had time to charge. So if you couple those together, those would be the most advantageous. And I think a lot of people aren't looking into it, because especially as somebody that would want to go into being like an entrepreneur, those are great opportunities. And there's, I don't know if I can say, there's funding out there for that.
Oh, yeah.
Plenty of funding. And it's needed, and it's difficult to expect the utilities to be able to create that demand, because we don't know what that demand would be. It's varying. You got EVs coming online, you know what I mean? You have the need for data centers. There's so much load growth right now that having these little small distribution systems, solar, battery, is a better way to go. And if I'll call it that distribution grid, if they can recapture or reclaim some of that, and potentially sell it back to the grid, that's even more beneficial.
And also, to piggyback off what she was saying, we in terms of technology, something that I think that has been is a really underserved opportunity are transformers. And believe it or not, the United States runs off of about 2,500 of them. And if you look around the United States, there's a varying level of upkeep that has happened over the past, just call it 30 years. Much of that equipment is aging. So because we have an aging infrastructure, it means that we're at a really delicate point in society, because if anything were to happen, and I'm sure many of you recall, I think this was this past summer when we had that huge solar flare and it caused the northern lights to be seen from Chicago, which is where I live. If that had been any worse, we would have had a massive blackout on the level of what's called an electromagnetic pulse event that would have sent us back to the Stone Age. So the fact that we're not investing more heavily into transformer technology to be able to step up and step down that power, and to be able to allow for all of these new sources of DERs, it's a really dangerous place to be. So that's, I guess, what I would add to that story.
Can I add inverters too?
Oh, inverters too.
Inverter
yes,
technology, and there's plenty of opportunities for that. Just throwing it out there. If somebody wanted to go into business with that, because you need to be able to transform something that's going online from your DER from DC to AC, right? So inverters.
And once again, if you are curious, we do have an actual virtual power plant inverter downstairs for you all to check out, touch, get up and close with.
Thank you.
Thank you. That was a great question. Yes, sir.
Sure. Good afternoon. My name is Paul Douglas. I want to start off by saying thank you guys for this conversation. It's pretty impactful. I own a company. We do work across the country in what they call energy efficiency, which is another type of energy. So we provide project teams in a variety of states to do energy efficiency projects. The one thing I wanted to kind of share with you guys, and I would love to get your feedback, we see a lot of, because energy efficiency is on the ground, our main goal is how do we get into low and moderate income homes, some of the poorest communities in the country, and get their utility bill to go down. So there's a term they have what they call energy burden. And in some of the states across the country, the energy burden is almost 30% of someone's salary. Some of us grew up in homes where the parents said turn the lights off, and I don't know why they said to turn the lights off. But
Air conditioning in the neighborhood.
I wanted to share that with you guys, because there's some students in the room today, and I can tell you guys that you're looking for a career that you can have an impact on people. And I think the energy sector is providing that opportunity. There's a lot of technical piece that we have some SMEs in the room. I come from the side of if we can decrease someone's utility bill, you change their lives.
Yep.
And that's why I wanted to kind of get your thoughts on how does energy impact some of those communities, and what are some things that these students can look for in future jobs to have that impact on those communities. Thank you guys in advance.
Yeah,
for that
thank
answer.
you.
Can I take it?
Yes, yes, sir.
Okay. Yeah, so just, I love that question. Thank you very much for that. As a case scenario, we've actually just signed up a municipality in the Chicagoland area, and we're doing exactly that. So what he's referring to with that field, we do something called energy auditing. And in order for, I guess, a municipality or even a homeowner to know exactly why their energy bills are so freaking high, they may not realize that they're using the wrong wattage of light bulb, or that they have cracks around their windows, which is allowing that excess air to get in. So what we do is something called a blower test. And the blower test will cloud a room with particulates, and we'll use like an infrared scanner to enable to see like where that energy leakage is coming from. Also, if you have like a second refrigerator, which many black households do have, that's just, I mean, it's consuming so much energy and it doesn't necessarily need to. So energy efficiency experts will say, get rid of those things, upgrade your electrical system, things of that nature. And there's a ton of opportunities. And I'm sorry, I forgot to even mention that, so thank you for that. When the first question was asked about entrepreneurial opportunities. So that's a really, really big one. And by the way, this exists within the residential space, but it also exists within the commercial space. And you can charge per square foot for that. Going into a warehouse, I mean, you do the math on energy efficiency for a 100,000 square foot facility.
The only thing else I'll add to that is utilities have a massive demand for entrepreneurs in this space. I know and you don't need to have a 100-person operation. They're
right.
signing contracts with 1-2-person engineering teams to go do this work. So anyone that's looking to go into the entrepreneurial place, this is a significant opportunity. And I always say this is one of the industries that have the volatility is not as much as other industries also. So if you want to get into a space where you're not worried about potentially being laid off, it's the utility and the energy sector. These are monopolies in a good way as well. So thank you guys again.
No, thank you. You like to comment on that?
Yeah. So so I think it's called STAR, the STAR rating, or
Yes, Energy Star.
yeah. There is certifications for that where a person can go in and get basically a person that goes to buildings, especially if it's a multi-unit or commercial or industrial, and give that property a star rating, and that means that that building is considered efficient, right? It's kind of passed the test for being able to reduce energy consumption, and a lot of utilities offer rebates for making your property energy efficient. They could even pay for that, so I always suggest that that's recommended to individuals, and sometimes it's just as simple as giving a local utility a phone call. And then I like the subject about entrepreneurs working with utilities. So I don't know if anyone's ever heard of like what's called diversity supplier. And I'm sure different companies have it. There are not enough diverse suppliers for utilities to work with. They find themselves having to keep working with the same ones over and over again because there's no one out there. And this is pivotal for younger people, for entrepreneurs coming up. You need to understand where the need is and be able to fulfill that need. And it's very tough to have a project that may be $100 million and we're like literally searching for a supplier that comes from our community that represents us, that will be doing work in our space, and they're not there. So now we have to go to the same company that really isn't considered diverse because they're the only ones willing to bid. They're the only ones who are willing to get the technical background to fulfill that space. So just please, if you can, spread the word about the importance of having representation from a supplier standpoint. Whether you're just supplying materials, whether you're, supplying like PPE or FR clothing and what I would have to wear frequently going on a job site, whether it's engineering services, drafters, designers. I mean, when you think of it, there is a need for it. If you just are just supplying paper, there's diverse suppliers that are needed for that, and they're just not there.
Yeah. And also to kind of end on that, I am also a certified energy manager, so what you can do with that certification is really, really useful. So in the instance of what we do when we go into a municipality, we have to conduct an energy audit just to see what the projections are for what they will need and where they are now, and that could incorporate things like doing residential and business inspections. But more importantly, we do something called a green energy plan. And certified energy managers are more than capable of conducting these services, and they're worth a lot of money because all municipalities around the world, or around the United States, let's not get crazy, around the United States, they have certain green standards that have to be met. So the fact that you can go to school for, I think it's like an 8-week program, more or less, and get those certifications and be up and going, create an LLC, and then just leverage your communal network, you could have your first couple of clients within the next 3 months from now. There's also the Certified Energy Auditor certification, which is a CEA, and all of these are really, really inexpensive things. Then you also have like the Buildings Performance Institute. I mentioned earlier about energy auditing within commercial institutions, and that's what you would basically need to approach. So that's called the BPI certification. I mean, the list goes on and on and on, but those 3 things right there will have you in really good shape if you're interested in getting into entrepreneurship within the energy space.
Yes, sir.
Hi, Samuel Obiora, Morgan State University. I just wanted to ask, so as the demand for AI technologies grow and other energy-dependent technologies, how do we balance like kind of that rapid rise in, I guess, energy use with like data centers and stuff, and also like transitioning to clean energy and kind of like keeping the supply available without like energy prices rising too heavily and like average consumers getting the burden on their backs. Like, is there and I know you said like nuclear, it takes a long time. So, but like with AI stuff, it's really rapid right now. So, I feel like the rates aren't like kind of going up at the same time. So, what do you think like about that and where that's going?
Me?
Yeah,
Oh, okay, sure. So, it is the reality of what's happening right now. I mean, there's definitely with more cloud computing, more data centers that are required. Like I said, EV stations coming online, more microgrids that are coming into the system. That grid reliability is extremely important, but also being able to keep up with the demand is really important. So there is a big push. I don't know if anyone's ever heard of net zero, where it's basically asking the generation side of the energy industry to reduce basically, I don't know how to say it, carbon emissions and other sources of pollution that could be deemed harmful to the environment. And they have a goal, I think the original goal was 2050, and now I believe it's being accelerated by a lot of utilities to like 2030. That's only a few years away from now. With that, you may or may not have heard that a lot of our fossil generation plants have went offline, like within a matter of like 2 and 3 years. And we're talking about hundreds of megawatts coming offline at one time. At the same time, the generation side of the industry is trying to keep up with wind turbines, being able to come up with solar farms. Solar farms take a lot of acreage to support. I mean, if you want to get like a 50 or 100 megawatts, you're talking maybe 100 plus acres just to support that. And then you have to think about analyzing, where's the sun coming from? Same thing with wind, where's the wind coming? You onshore or offshore? Like it's sometimes the environment may not be right for that. And the states have their own regulations about how much can you have of each one within that state. So there's some limitations to that. And then there's placing it in areas where it's sustainable, because rural areas may not have the generation that is needed. Just historically, they didn't need it before, but now you think about how much more load is coming online in those areas and how they're growing. And now they need it exponentially. So it's a difficult balance to try to meet the net zero requirements by taking fossil fuel sources offline and bringing in renewables to support that. But then now we have to consider, is that really the right move? Everyone across the states is considering it, not just from a regulatory standpoint, but making sure we still maintain grid reliability. So some sources where we were hoping to go away from, like maybe gas, now is becoming a more viable sources. Some, like for instance, with nuclear, with 3 Mile Island, where it may have never been considered like 5 years ago, are now becoming considerations because the amount of generation that's needed cannot necessarily be met with all the renewables that are out there. So we have to be able to diversify the portfolio and consider like what type of mixture can we have? Can we have gas? Can we have combined cycle? Can we have solar, or do we want to mix solar with battery energy storage? You know what I mean? Like, can we bring nuclear back online somewhere? It's a very complex question. It's not an easy answer, but a lot of that is being considered by looking at data analytics, seeing what type of load we need in different area, what's the expectation from load growth, and monitoring that. I'm hoping I'm answering it, but it's so complex that there's no right or wrong answer. It's just like
Lots
how
of
do we,
opportunity there.
lots of opportunity, and how do we plan in advance for it? Because we can't wait until the day of when we met low capacity to resolve it. It has to be done well in advance.
Yeah, and also to add to her point, small-scale energy generation is the hill that I'm planning to die on, because I realize that you can have it up and going, and in that defense, with creating, I guess, meaningful solar farms, it does take a lot of acreage. However, if you have small instances of that, like a 100 kilowatt system, which is what we're doing, we set up, we're trying to do a 100 kilowatt system every couple of months to reach megawatt capacity, but we're doing that in less than 2 acres, right? So to have all of these disparate sources all over the place in strategic areas, that enables us to move really, really quickly. And what's more is it doesn't take long to get up and going once the systems are built and commissioned. More importantly, what I wanted to share is there's a new initiative that exists, and I kind of took a shot at my competitors, but they do something called demand response. So demand response is basically them working with partners that says, hey, we're reaching peak capacity or peak load, can you turn off your stuff? And to me, that's like a Band-Aid on the bullet wound, but it is useful in certain cases. But realistically, if you're playing your Xbox or something, are you going to turn it off? No. Probably not. So hopefully that answers your question.
It did. Thank you.
Thank you. We've got about 5 minutes left. We've got time for maybe 1 or 2 questions. So I want to make sure that if you've got that burning question, we get a chance to put it on the table. Yes, sir.
Yeah. My
You're
name
the
is Harry.
You're the first one to pick up the mic today. You must be an MC.
Yeah, I want to hurt my back. My name is Harry McElroy. I'm with an AI company called Performagence. And we've been entertaining some research projects along with USDA in the area of biofuels, like food waste, brown grease waste, and the nature, and such as that. And when I was at lunch today, looking at all the chicken that was gathered, chicken waste, it made me think that maybe that is actually a viable something that could go beyond just this research that we're doing. So I was wondering what your thoughts are on that.
I completely agree with that. I mean, in all honesty, there's so much research that's going to it where you have a lot of entities who have already developed test sites, and they are testing biofuels as a source in combination with some of the other more common renewables that we talked about today. So I wholeheartedly believe that that's going to be a part of the renewables mixture. It's already being tested. It's already being, considered in what we called community outreach type of projects, where we want to be able to provide renewable resources that may be sustainable, but in areas that may be disadvantaged. So there is a lot of effort that's being put into it, and I will say that there probably are opportunities for funding as well for entities who want to pursue it.
And not to overshare, but my organization is also looking into algae biofuels. So that's another entrepreneurial possibility. So for those who don't know, there's a certain type of green algae that reproduces really, really quickly, and there's an entire distillation process where it can be rapidly converted into diesel fuel. So that's something that could be of really, really good scale value once we kind of get through this initial R&D period.
Just to follow up on your question, I'm a chemical engineer working for Wood, and we've done some pretty big projects on sustainable aviation fuel. Wood PLC, and that's a big vector for things like grease, vegetable oil, animal fat, because there's no, renewable electrification for something like a jet plane, so it will need a form of kerosene aviation fuel, but the source of that, if it is renewable, will be swept up and will be actually very valuable. So,
Okay, we got 5 minutes left. I think we got time for 1 question, if not. If there are no other questions, I'd like to revisit one of the questions that I think one of the gentlemen right behind you in the blue suit, I think he had earlier. and I wrote a few notes down, but I want to make sure that we had time in the end to kind of come back to it. But he talked about R&D, what type of skill sets that you would look for in a student, or what type of research and development areas that you're looking at for energy, or in my case, I look at energy as a national security imperative. And so where I see risk to energy is, and I see risk in the AI realm, and some of the things that we look at is, he talked about computer vision at monitoring things. Well, there's so much feed from overhead sensors, so many images or data points, that it takes an AI model to actually understand what that imagery is telling you, right? So if you're looking at smokestacks, or you're looking at heat signatures, or you're looking at chemical or biological markers that coming from a plant, the AI algorithms should tell you, or should give you a pretty good indication of what's happening there. And so those are some of the fields of research that we're looking into. Another thing is, as we start to connect these distributive resources together, right, there's always time for nefarious actors to get into that environment. So some of the things that we look at or look for are, who's studying poison AI or Trojan AIs that you're putting in there to shut down our national energy grids. So those are kind of things that I think, at least from a Department of Defense or Department of Energy, those are some of the higher level security things that we look for in an AI, So I hope that answered part of your question, sir.
Yeah, thank you. And I mean, even on that note, as a virtual power plant, and as I mentioned, distributed energy resources is the hill that I will die on. You also have to realize that in employing AIoT, there is a massive amount of what's called fail points that can be easily targeted. And the fact that we're able to remotely control all of our energy assets, it means that someone could overload the system. But fortunately, we have an incredible team, and it's enabled us to kind of suss out, if you will, some of the major factors that could lead to some cybersecurity attacks taking down our entire grid. But we don't have all the answers. And I was on a panel yesterday, and one of the cybersecurity experts, he said something to the effect of, there's no such thing as safe, it's just how much money do you want to spend? So hopefully that helps answer.
So folks, we're getting a hook here. But first of all, I want to thank my impromptu speaker here. How about a big hand of praise for Miss Sharia Brown?
Yes.
Sharia Brown, so thank you very much, and that's very, very, very helpful. And again, Mr. David Jones.
Thank you, sir.
So thank you. I hope I got the right color badge there. And I thank you. And I want to remind you all to make sure that if you see the surveys, take the surveys, make sure that you get a chance to comment on it, feedback on it. Make sure you talk about potential guests for next year as well. And then make sure that if you're getting your continuing education points, that you sign up with the Morgan State table out front. But other than that, please enjoy the rest of the conference and continue to network, continue to carry the conversation throughout the rest of the conference and throughout the year. Thank you.
Thank you.
Thank
Nice
you.
to meet you.
That was great.
Thank you.
Yeah, I've never,
Happy
no, it was great.
Nice to meet you.
That's all right. That's all right.
I am.